When we measure a variable, we need to pick an appropriate scale of measurement. We can classify 4 different scale levels of measurement. These 4 levels are nominal, ordinal, interval, and ratio. These intervals are listed with nominal being the lowest level and ratio being the highest level. Each successive level of measurement adds additional information beyond that contained by lower levels. First, let's discuss the nominal level of measurement. Nominal scales use names and categories. There is no way to order these categories in any meaningful way. Some examples of nominal measurements include favorite sport, ethnicity, favorite pizza topping, and shape. Looking more closely at favorite sport, responses of basketball, football, and soccer all indicate different categories, but there is no order to these responses. Even if we designate a variable to represent basketball by the number 1, football by the number 2, and soccer by the number 3, the order of these numbers would have no meaning. Now, let's talk about the ordinal measurement level. Ordinal measurements, like nominal measurements, consist of names and categories. However, unlike nominal measurements, ordinal measurements can be meaningfully ordered. Importantly, however, distances between ordinal measurements cannot be compared, and the distances between 2 consecutive pairs of ordinal measurements cannot be assumed to be equal, even if numbers are used for the names and categories. An example of ordinal measurements is responses on a scale measuring how much someone agrees or disagrees with a statement. With the 5 options, strongly agree, somewhat agree, neither agree nor disagree, somewhat disagree, and strongly disagree. These 5 categories are ordered from strongest agreement to strongest disagreement, but you can't say that the distance between strongly agree and somewhat agree is the same as the distance between somewhat agree and neither agree nor disagree, and you can't compare the distances between any 2 pairs of these responses. Another example is rankings. For example, ranks of cities by population, where 1 represents the most populous, 2 represents the second most populous, and so on, provide measurements that have meaningful order. A city with rank 6 is more populous than a city with rank 12, but we can't compare distances between ranks or use ranks for calculations. We don't know whether the difference in population between cities with ranks 4 and 5 is the same, greater than, or less than the difference in population between cities with ranks 10 and 11. And we can't say that a city with rank 12 is twice or half as populous as a city with rank 6. The next highest level is the interval level. Variables of the interval level are similar to the ordinal level variables in that they are names, categories, or numbers with meaningful order. Unlike with ordinal scales, interval scales have the added feature that adjacent categories are equally far apart. As a result, intervals between any 2 consecutive pairs of measurements on an interval scale have the same interpretation, and distances between any 2 pairs of measurements on an interval scale can be meaningfully compared. However, an interval scale has no true zero value for measurement, even if there is a value defined as 0. 0 does not represent an absence of measurement. As a result, comparisons using ratios cannot be made using interval scales. An example of an interval scale is the Celsius temperature scale. Intervals on the Celsius temperature scale are meaningful and can be compared. The distance between 3 and 4 degrees Celsius is the same as the distance between 43 and 44 degrees Celsius. However, even though 0 degrees Celsius is defined, a measurement of 0 degrees Celsius does not mean there is no temperature. You also can't make meaningful ratio comparisons using the Celsius temperature scale. 40 degrees Celsius is not twice as hot as 20 degrees Celsius. The highest scale level is the ratio scale. Ratio scales have the qualities of nominal, ordinal, and interval scales in that measurements are names, categories, or numbers, they have a meaningful order, and intervals are the same. However, ratio measurements include a meaningful absolute zero value. As a result, ratio comparisons can be made for measurements on a ratio scale. Some examples of ratio scale measurements include money, length, mass, and volume. For all of these measurements, a measurement of 0 implies the absence of such a measurement. You can also make ratio comparisons. Using length in inches as an example, something that is 10 inches long is twice as long as something that is 5 inches long.